Previously, we talked about the LCSolutions software and just how to access it from the desktop and maybe what a few of the buttons mean, not many of them, but a few. And now we're going to go even further into detail on the software. And it's going to be so much, hopefully, not really, but you'll be ready to just put a stop to this video at the end of this one and say, no more of this software, I can't take it, please. Okay, so let's look at the Data Acquisition tab. This is where we left off. So under the Data Acquisition tab, you're going to see something that's called LCTime Program. And this says LC stop time, and right now it's set at 5 minutes. Okay, the purpose of this time is to tell the machine when you want it to stop the analysis run. So right now as it sits, this machine will stop the analysis after 5 minutes. So I've got to know a little bit about my sample that I'm running on the machine before I can determine what this cutoff time is. So that means I'm going to have to extend it in the very beginning, maybe put it at 30 minutes. And then in 30 minutes, I'll see what time that component comes off that I want to know more about. Maybe it comes off in 10 minutes. So what I would do is that on my next run, I would go in and I would change this value to maybe, well, not 10 minutes if it's coming off at 10 minutes. So I'll overshoot it a little bit and I'll put 12 here. And this tells the machine, run for 12 minutes. And after 12 minutes, we want you to stop that sample, and we want you to inject the next sample that's in the tray, that's waiting in line. So you've got to know a little bit about how long these components are taking to come off of the machine before you can make this judgment call. Now, if you are in a laboratory and you know that you are injecting maybe something like caffeine, well, caffeine takes around 5 or 6 minutes to come off, maybe for a method. So you want to put that on there, but you're going to have to inject a sample of caffeine first. And then when you make that determination, you can go back in and make these time changes. If you're watching this because of the Chemtechathon competition, we are going to tell you when to stop it. We don't want you to waste any time trying to figure out, well, when does this component come off? When should I make this machine stop recording information? So we're going to tell you the stop time on the handout that we provide you for that day. And this is where you will put that time. So on the handout, if it says the stop time is 8 minutes, you're going to put 8 minutes in here. If the stop time is 25 minutes, you're going to put 25 minutes there. So we're going to change this to 6. It was at 5. We'll change it to 6. And then what you do is that down here below, you are going to put apply to all acquisition time. So you press it, and when you do that, it sends a signal to the machine that everything needs to stop at 6 minutes. The pump needs to stop, the auto sampler needs to stop, the mobile phases need to stop, the detector needs to stop, everything needs to stop at 6 minutes. And then the machine will reset itself, and then it's ready for sample number 2. Over here to the side, you see this acquisition time, and it says UV vis detector. There's nothing that you have to change here. By clicking apply to all acquisition time, you have automatically forced it to go in all the places that it needs to go. And notice 6 minutes now is showing up here at the end time. Now watch what happens if I change this to 8 and I put apply to acquisition. That now changes to 8 automatically. So that's why I'm saying use this as one fell swoop. It takes care of everything. That's why that button is there. So that's the tab with data acquisition. It only wants to know how long do you want it to acquire data. There's no sense in running this machine for 30 minutes if your stuff is coming out in 3 minutes, right? That's wasted time, and that's something that we want to prevent because time is money, and money is a paycheck. All right, the next tab over is called LCTime Program. If I click it, there's nothing that I have to do on this tab. The reason is because I clicked the button that was before that says apply to all acquisition time. So this is really looking at the controller, and the controller is what makes the instrument work. It's the piece that talks between the instrument and the software. So we're telling the controller, 6 minutes, we want you to reset, and we want you to go to sample number 2. So there's nothing here that you have to change. You leave it alone. Next tab, pump. I'll click it. Now this box pops up. There's more tabs for me to choose here. So remember back in the previous modules or grouping of videos, we talked about the mobile phase tray. And we said the mobile phase tray had line A, B, C, and D coming from the top. And this is how you make the machine understand what you want it to pull. Okay, well, here is where that comes into play. So what we see is a tab that says pump, and this pump, well, the mode says low pressure gradient. Do not change that. If you click the drop down tab, you'll see isocratic flow or pressure gradient. You don't have to change either one of those. Okay? Leave it as default. Whatever shows up that day, do not touch it. But here we see some tabs. One of them says total pump A flow. Okay, so this is how fast the machine is pumping the mobile phase through. Now, this flow rate depends on what kind of laboratory I'm going to be doing. Sometimes it requires a quicker flow rate, sometimes it requires a slower flow rate. It just depends on what I'm trying to analyze. Well, the labs will tell you what flow rate you need to be using. Whatever that flow rate is, this is where you're going to put it. Remember, we said that you probably won't see anything lower than a 0.500, and you probably won't find anything higher than a 1.500. Okay, so because of that, if I go back and I change this to, let's say, 0.75, well, let's say that's what my handout tells me to do. It tells me this is your flow rate. You want to make sure that your flow rate is set, and there it is, 0.75. Down below it says solvent B, solvent C, solvent D, and all of a sudden you're saying, well, where's solvent A? Right? I should have solvent A here. Well, the software is built so that any remaining percentage is pulled from A. Okay, so if I look at solvent B, C, and D, let's just change all of these to zeros. If I leave all of these at zeros right now, and I hit OK and make this machine start running, 100% of the mobile phase will come from jug A. Whatever is in jug A, who knows? Right now it's methanol, but who knows what's up there? But 100% will come from that jug. By default, that is how it interprets the information. Okay, well, solvent B, in this case, my solvent B is water. So what would happen is that solvent B, let's say I want to do a 80% methanol, 20% water. Well, I will key in 20% there, and that's all that I have to do, because the software understands that the other 80% will be coming from the A jug, and that is why A is not listed. It's kind of like a self-check. It doesn't trust you to enter numbers in to add up to 100. It does it itself. Well, we have a quaternary pump, and it can pull from 4 different jugs at one time, and that's why you're seeing a B, C, and D listed. I can actually go through and key in a different percentage on each one of these jugs, and the machine understands what to do. It knows, okay, well, if these are the settings that you're going to give me, I'm going to pull 5% from solvent D, which is a buffer right now that's loaded on the machine. I'm going to pull 10% from solvent C, and my solvent C is acetonitrile right now. And I'm going to pull 20% from solvent B, and that's water. And then the remaining percentage I'm pulling from A, which is my methanol jug that's on the instrument. Okay, so 20 and 10 is 30, and 5 more is 35. So 65% will be pulled from A. That is called the mobile phase composition. One of the most important settings that you can pick on the software itself. So this is very important, right? Whatever's up here, you leave this as default. Now that's isocratic flow. This is me only pulling from one jug and that's it. Low pressure gradient is typically what we use on this instrument, and these are the settings and the way that you make the settings on the software so the machine knows what to do. This data will be given on the lab practical for that day. You will go in, these will already be determined. You just need to demonstrate that you know where those settings are going to go, and that's where you will key those in. Okay. Over here to the center of the screen it says configured pumps. You don't need to worry about any of it. We have a pressure limit on the machine at 3,500 psi. That's so we don't blow the machine up. If it gets too high of a pressure, the machine has an automatic shutoff that it does. And then we've got this valve, pump A, B, C, and D. That is grayed out as well. You do not need to do anything there either. So that is the pump tab. So in the next video, we'll continue on and we'll look at detector A, controller, auto sampler, and the auto purge tab. So I told you, you won't like these as well, but it is software driven, it is computer driven, and if you're tech savvy, then you shouldn't have a problem with the software at all. But for some people, we need to go through these steps a little bit just for some extra coaching.